Hello, everybody, and welcome back. Ooh,
Both the first and second stages are.
could you tell I haven't streamed in like a year? Anyway, hello, everybody, and welcome back to GeForce. Today, we are watching EarthCARE launch aboard Falcon 9. We are about T minus 3 minutes from launch, and you might be wondering, what is this launch? Or what is the payload? So, the payload is, as I said, EarthCARE. And what is EarthCARE? EarthCARE is a satellite that is meant to help scientists understand the relationship clouds and aerosols have in reflecting incident solar radiation back into space and trapping infrared radiation emitted from Earth's surface. And you may be wondering, what is incident solar radiation? Well, that's just solar energy that strikes the surface over a period of time. So basically, they're just trying to find, or they're just trying to find that relationship between that kind of radiation off the clouds and aerosols, um, and related to like climate change and a bunch of other things like that. So, yeah, that's what this mission's about. We are about T minus 2 minutes, and coming up pretty soon will be the startup. And startup is when the Falcon 9 will get control over itself. Is we will no longer be controlled by the ground, and the rocket has the authority to launch at T0, abort, or hold. And if it aborts, there will be no launch today. If it holds, there's a chance there might be a launch today, but it will get delayed, and it'll get delayed by a while because usually it takes the ground crews a little bit to figure out what's going on with the rocket and if it's safe to proceed or if it's not safe to proceed. So those are the three outcomes, at least for pad wise. When it gets off the ground, the rocket has the authority to pull the FTS system. The FTS system is a flight termination system. So if something goes catastrophically wrong with the rocket, it can elect to fire some explosive charges in the rocket and blow itself up. And that is a last case scenario. That is like if something absolutely dire is going on, then it will use that. But hopefully that won't happen. And we should have a good launch here. And I just got the confirmation, or I just heard the confirmation on my headphones that Falcon 9 is go for launch at about T minus 30 seconds. So let's watch this thing get off the ground and into space. Turn on the desktop audio that we all can hear.
T minus 15. T minus
10,
10,
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff.
Go Falcon 9, go EarthCARE. Vehicle pitching coverage. Days on chamber pressure normal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 4 East.
And there we go. Falcon 9 has just lifted off, and we are quickly approaching max Q. So, what is max Q? Well, max Q is the moment where the rocket is under most pressure. And during that time, the rocket is transitioning from going subsonic, anything from about Mach 0.85 and below. When you walk, you go subsonic. When you fly on a plane, you go to the very edge of going subsonic. But it's in this max Q phase, it's transitioning between subsonic and supersonic, which is Mach 1 to Mach 4.9. And this rocket, it's really easy to tell when it's going through max Q because you could see kind of like a giant jet contrail. That's the best way I could describe it, is a giant jet contrail. You can see that pretty clear if there's not like heavy cloud cover. Um, And from that heavy cloud cover, you can see a like a what looks like a jet contrail, and that's how you know it's going in that what's called transonic. It's going through that transonic region, and once it passes max Q, it's going Mach 1, or actually going past Mach 1. And you can see we passed it a long time ago. It just took me a while to explain that. And it looks like we are coming up on MECO, or main engine cutoff. And what this... Actually, I did not see that. This launch is doing a RTLS landing, which means it's a return to launch site landing. So basically, what this will do, and you'll see it happen in just a minute, but the booster... Oh, it's using a small nozzle. My bad, I got distracted. But... And we should have MECO now. And stage separation. I'll explain that small nozzle in a minute. But, so you can see it now. It's doing what's called a boost back maneuver. And there's second stage ignition. And so basically what the booster does is it flips a 180 and it burns back. And it goes the opposite way. And then it re-enters the atmosphere and then does its normal landing procedure. But it lands on a landing pad only about 5 or 6 miles from where it launched. It's going to be crazy if you haven't seen one before, and it's the craziest thing to see. But yeah, let's go ahead and explain this small nozzle. So SpaceX unveiled this a while ago. I think it was like about a year ago, about the time that I stopped streaming last. But I think they unveiled it about a year ago, and so basically. So if your satellite doesn't need that much thrust, like you can handle losing a little bit of efficiency, losing a little bit of power, but it's going to be a cheaper launch, you could go for this shorter nozzle option. And I don't know how much cheaper it actually is, but it's a good bit cheaper. And if your satellite's under the weight limit, it can still send your satellite to where it needs to go pretty well. And yeah, I guess they chose on this one that the satellite was small enough that it didn't need the full nozzle. And they went this small nozzle. And so now we are just kind of coasting along here, waiting for the booster to do its entry burn and waiting for orbital insertion on the second stage. So I guess I should blurt out a few more facts about EarthCARE whilst we're at it. So a little bit about the orbit it's going into. It's going into a sun-synchronous orbit, which, if you don't know what that is, basically, it's relative to Earth. This is kind of what I understand. It's kind of like it's pretty much orbiting the sun. Hold on. It's pretty much orbiting the sun, but it's also like, well, okay, all sides orbit the Earth and kind of at the same time. But basically, it's synced up with the sun, so it basically kind of stays still at one point on Earth while the Earth spins, which isn't true. It does go around Earth, but it's, I don't know. Here, let's look up the definition. Sun synchronous orbits. Okay, so I was way off about that. Throw out that other definition. So it's a orbit that's almost polar, and so it's pretty much a polar orbit. Like actually, this launch is about 97.1 degrees, and so it's basically sun synchronous just means that it's just going pretty much polar. So yeah, I'm gonna hand over SpaceX. I have something that I need to do right quick. So yeah.
We should hear the call out for the entry burn on the Falcon 9 first stage.
Stage 1 entry burn startup.
And there's that confirmation of entry burn startup. This burn will last about 20 seconds and will slow the vehicle down in preparation for the landing burn.
Stage 1 entry burn shutdown.
And there's confirmation of Stage 1 entry burn shutdown. We're now waiting for Falcon 9 to land back at Landing Zone 4 at Vandenberg Space Force Base in California. And it just so happens that Landing Zone 4 is actually only about 450.
Both vehicles are on nominal trajectories.
All right, here we go. I am back. So looks like we've already done the entry burn, which I'm pretty sure they explain on there. But basically, there's like 3 engines, and it slows down the rocket. That way, it doesn't disintegrate on re-entry. So, yeah, that's what's done. And what you see on the camera is probably all the soot from that from those rocket engines burning, the ablator wearing off, and all that. So now we should be coming up on the landing burn, and we should be able to see the landing from the ground. Oh, there we go. There's the landing motor. We should be able to see the landing from the ground here. So now we'll wait. Any minute here. And there we go.
And there you have it.
And
Falcon
there we
9
go.
has
That's a
successfully
successful first stage
Falcon 9 has
landing
successfully
burn. And yeah,
Stage 2 is in terminal guidance.
it's so weird how they make that look so routine, because it
Falcon
is
9 has successfully
definitely
landed at Landing Zone 4
extremely
at
hard to
Vandenberg.
do. If
This
you
was the
haven't
7th
seen how
launch
not
and
to land
landing
an
for this
orbital
first
rocket,
stage. And
you
this
should
landing
watch
marks
that.
SpaceX's
It's a compilation of
314th
all of
recovery
SpaceX's
an orbital class rocket,
attempts
including first stage
to land
landings
a,
for Falcon 9
all
and
their
Falcon
failed
Heavy.
attempts to land a booster before they got a successful one. And yeah, it's
Coming up
actually really
next, we'll
cool,
hear a
because
call
now,
for
I mean, if you
Seco
look at
1
it, they've been doing
second
this for
engine
like
cutoff 1
5 or
on
6
the
years
Falcon
now,
9
and it's
second
just
stage currently on your screen.
it's just so crazy how routine it looks.
And
Man, can't you tell I haven't done this in a while? Yeah, I left that audio on. My bad. I probably just got all jumbled up. Alright, so looks like in that time we have had Seco 1. So, now I guess whilst we're in that time, from Seco 1 to deploy, I should explain a lot more. I should go through my fact sheet. So the EarthCARE mission, so that's actually an acronym. EarthCARE actually stands for Earth, Cloud, Aerosol, and Radiation Explorer. It is a joint venture between ESA, JAXA, and NICT. This satellite is the 6th in ESA's Living Planet program. If you don't know what the ESA Living Planet program is, it is a program designed to monitor various environmental aspects of Earth. There are actually 2 types of satellites, Earth Explorers, like EarthCARE, and these satellites conduct research, and Earth Watchers, and these are kind of like weather satellites. They provide information such as weather forecasting and resource management. And I said at the beginning of the stream, but I'll redo it. I'll re-say it. So the mission of EarthCARE is to help scientists understand the relationship clouds and aerosols have in reflecting incident solar radiation back into space and trapping infrared radiation emitted from Earth's surface. And if you don't know what incident solar radiation means, it's basically just solar energy that strikes the surface over a period of time. And this satellite uses LiDAR and radar technologies that have apparently unseen accuracy for a satellite of its class, so hopefully the satellite's going to be pretty accurate. And some information about its orbit. I already said it's going to be sun-synchronous. I had that whole, like, sun-synchronous is one thing, but turns out it's a completely other thing. Yeah. Oh, and there's deploy. There we go. And alright, so it's in a sun-synchronous orbit. It has an orbital inclination of 97.1 degrees. It utilizes 2 radio bands. The S band, which is for TT&C or telemetry tracking and control, and the X band for scientific data. The satellite costs about $810 to construct, and it is the largest Earth Explorer to date. And that is all my information. I actually want to show you a little slideshow that I have that goes over the various instruments on the satellite since the stream is over. Let's see here. So let's go here. Let's present the slideshow. And yeah, here are the EarthCARE instruments. So the first one is called atmospheric LiDAR, or ATLID. This provides profiles or vertical profiles of aerosols in thin clouds. It operates at a wavelength at 35 nanometer or 355 nanometers, which is in the ultraviolet spectrum. It utilizes a high spectral resolution receiver and depolarization channel. The next instrument is called the Cloud Profiling Radar, or CPR. This instrument provides vertical profiles of clouds, and it observes vertical velocities of cloud particles through Doppler measurements. It operates at a frequency of 94 gigahertz. The Multispectral Imager, or MSI, provides... Oh my gosh, I cannot talk. My bad. The Multispectral Imager, or MSI, provides a cross-track information on clouds and aerosols. It has channels in the visible, near, infrared, shortwave, and thermal infrared bands. And this should be the final instrument, which is called the Broadband Radiometer, or BBR. This provides measurements of the top of the atmospheric radiances and fluxes. It has two channels, a shortwave and a longwave channel. These two channels have three viewing directions. Nadir, which is basically, it's like if you're standing, nadir is just down, like below you. And it has aft pointing. And yeah, that is the final instrument. So, there we go, ladies and gentlemen. That is the stream. That is the first time I have streamed in about a year, and it kind of shows. But honestly, I don't think that went too bad. So, ladies and gentlemen, if you have enjoyed this stream, please consider liking and subscribing. And as always, thank you for watching the G-Force. Anyways, thank you for liking, or if you've enjoyed the stream, please consider liking and subscribing. And as always, thank you for watching the G-Force.